In this lesson, we'll create a canned threading cycle. So I'm going to use my view sheet here, double click and get my 2D profile up. I'll come up to the turning tab and grab the thread toolpath. So I am in the left upper axis combination. You see that it did filter to a threading tool for me. I'll go ahead and put a comment in. We're going to create a 9/16 18 left hand thread in the left spindle. Please note the feed rate here and the spindle speed. We haven't told her what we're doing yet. We will in a minute. So next I'm going to go to the thread shape parameters. First thing I'm going to do is I'm going to select from the table, and I want to select my thread form. So I have a variety of different thread forms I can select from. I'm going to grab a UNC-UNF, Unified UNC-UNF, and I need a 9/16 18, which is 562/18. That's UNF fine, threads per inch. So we'll grab this, and you'll notice it's updated some of my values here. It's currently displaying it in threads per inch. I'm going to go back and look at my feed rate here. Now my feed rate is 11 inches per minute based on this spindle speed. If I change my spindle speed to 1500, you'll notice my feed rate changes. I'm in inches per minute. I'm going to go ahead and change this to inches per rev, which is probably preferable for most folks. If I change my spindle speed here, I'm in the same feed rate because I'm inches per rev. So we'll leave that at 1250. I'm displaying my lead in threads per inch right now. If I change that to inches per thread, it shows the actual pitch or the feed rate that I'll be creating when I create my NC code. It does not affect my feed rate. Matter of fact, the feed rate and the inches per thread are one and the same. I do have an included angle of 60 for a standard thread. My thread angle is 30. Now the major diameter and minor diameter I got from the table. I do have a start position of 0, and I'm going to select my end position here. So I'll come out to the graphics screen. We're going to thread here. I've got an undercut created for it. I'm going to grab this as the end of my thread. So it's 1/2 inch. We are on the OD. We have no taper angle. Now I do have allowances that I can select from a table. The allowances are there to adjust for the class or type of thread we're going to cut. So I'm going to select from the table, and we need to select the class of thread that our print calls for. So we're going to make a unified 1A and 2A UNC-UNF. We'll come down here and we'll grab our 9/16 18, and you can see the adjustment it's going to make here. It brings that value back, so we'll adjust our major and minor diameters by that amount right there based on our thread class. We can compute our thread from a formula here. We're going to use the table in this case. So if I come to my thread cut parameters, I have a few options here. I can do it longhand. I can do a can cycle, which is what we're going to do. I can do a box move, or I can do an alternating type move. I do want to match the amount of cuts I want to the recommended amount of cuts from the thread tool manufacturer for the type of material and the type of thread and the type of insert. So I'm going to leave that at 5. You can see what the other parameters do on the thread here. We've got a clearance of 100 thousandths. I do want to make an overcut here because I'd stopped the thread at the back side of the wall here. So we're going to overcut by approximately 1 pitch, which would be 60 thousandths. I am not going to do a pull off. We do have a distance for our acceleration, so our spindle can get up to speed. We do have a lead-in angle, and if we wanted a finished pass allowance, we could have one here. This does give us the amount for the last cut, and we are going to make 1 spring cut. If we wanted more, we can put it here. We do have an option for multi-start, which we could use if we had a multi-start thread, which we don't in this case. So I'll turn that off. So I'll go ahead and green check, and I'll go and take a look at what this toolpath looks like. We got 1, 2, 3, 4, 5 passes, and then a spring pass. There's our 100th clearance. There's our 200 thousandths of lead in. So there's our threading cycle. Now let's take a look at what that looks like in Verify. So I'll go up and I'll select Verify. It will verify it against the stock that I've created. I am on a little bit of a slower setting here. I'll go ahead and run that. So we roughed it and finished it. We're grooving it. And there's our thread cycle. And you'll notice if you look at this, this is in fact the left-hand thread. If I wanted a right-hand thread, I would have to start from the inside and move out, or I'd have to get a different hand tool. So there is our threading cycle. Let's go ahead and post this operation, see what it looks like. So I'm going to select just a lathe thread. I'm going to go to G1. We'll select the green check. I don't want to post all, so I'll say no. Go ahead and put it where you want. I'm going to replace what I already have there. So I'll go ahead and reload that. So you can see that we did output a G76. We have the 2 lines, and MasterCAM put all the values in the appropriate places to create this G76 canned cycle.